In this tutorial, we are going to tackle two aspects of integration. That's, we are going to look at the definite integral, and also we'll talk about integration by substitution. So, definite integral, what is it about? So, we saw that this is the integral sign. Are we okay? And when we talk about the definite integral, it is an integral in which limits are applied. So, we have what we call limits. Are we okay? And here, when you write the integration sign with limits, for example, it's supposed to have a and a b, where a is what we call the lower limit and b becomes your upper limit. Are we okay? So any integral sign you see with this limit is called a definite integral, meaning that function can be evaluated to a single what answer. For example, if I have the integral of a, b, and cx, I can integrate this to a particular what answer, let's say d. Are we okay? And let's also not forget that anytime we integrate a definite integral, we don't add the constant again. So the constant, that's our c, is not introduced in definite integral. This is because it will cancel out. First, let's look at some ideas under the integral before we start. The whole idea behind the integration, we want to know the idea behind the integration. That's the definite integral. So this is what we do. For example, if I have the integral of a, b of a certain function cx, this is going to give me, I have to integrate this function, which is going to be cx squared on what? 2. Are we okay? And I'll bring the integrals, the limits, which is a and what? And b, in this way. So now I have to put in the limit at the position of the x and evaluate this function. So this is what we are going to do, which is equal to, always it is the upper limit minus the lower limit. That's what? The upper limit minus the lower limit. Are we okay? So this is the upper limit, the b, meaning I'm going to have c by b square on 2 minus the lower limit, which is also going to be the same thing, c by a square on what? On 2. And you can evaluate this function. Are you okay? Now let's take some examples and evaluate them and see how best we can do it. Are we okay? So now we know how to evaluate the integral sign. So I can take an example. So first, let's find the integral from 1 to 3 of x squared dx. Are you okay? So first we have to integrate the function. And if you integrate this, you are going to get s cubed on 3. Are you okay? But since it is a definite integral, we are not bringing the c. Are we good? And we will introduce the integrals here as 1 and 3. So we are to put in the values of the limit and evaluate. It's always the upper limit minus the lower limit, which is going to be this 3 into the place of s cubed on 3 minus the lower limit 1 cube on 3. And when you evaluate this, you are going to get 26 on 3. Are we okay? So the same way we can evaluate that. Number 2, integral of negative 2 to 3 of 4 minus x squared. Are we okay? So let's try to evaluate that. First, we have to integrate this function, then put in the values of the limit. This is a linear integration. It's the same as integrating them term by what? Term. And when I integrate the 4, I'm going to get what? 4x. When I integrate this x square, I'm going to get x cubed on what? 3. Since it's a definite integral, there's no need to bring what? The c. And I'll bring my limits, -2 and 3. So I have to put in the values of this and evaluate. That will be for the upper limit 4 by 3 negative, this will be 3 cubed on 3 minus the lower limit, which is -2. So 4 by -2 negative, we have this -2 cubed on 3. And when you evaluate that, you are getting 25 on 3. Punch it on your calculator. So this is all about the definite integral. You just integrate your function, put in the values of the what? The limits, which is the upper limit minus what? The lower limit. Are you okay? All right. So let's take this part, integration by substitution. So we are looking at integration by substitution. Substitution. What do we mean by integration by substitution or using substitution? Sometimes some integrals cannot be integrated just ordinarily. We have to do some substitution in order to help us. So let's take this example and see. If I have the integral of cos 3x 7 dx, are we okay? In the previous episode, we saw how to integrate a cos function, the shortcut. But here we are to show work and to tell the approach we went through. So here we can do integration by substitution. So here what we are going to do is we let this becomes a certain variable. So I'll say let u be equal to the whole of this of the cos function plus 7. Are we okay? And after making u equal to this, you differentiate the u with respect to the variable, which is x. So I can get the u with respect to what? X. And that is going to give me what? 3. Looking at this function, I said here is now u. I cannot differentiate u with respect to x or integrate u with respect to x, but I can integrate cos u with respect to what? Du. So here I have to make the function in terms of what? Du. Therefore, I will say my dx is now equal to du on what? 3 from this. Meaning the function this, which is integral of cos 3x plus 7 dx is now equal to integral of cos, this whole thing is now u, and this dx is now du on what? 3. Are we okay? So the 1 on 3 is a constant, so we can bring it outside the integral sign and get our cos u du in this. So you have to integrate u with respect to u, not u with respect to x. Here we know that anytime we integrate a cos function, what do we get? We get a sine function. Are we okay? So we integrate a cos function. So cos integral of cos x is equal to what? Sine x. Meaning we are going to get our sine function here. This is going to be 1 on 3 integral of cos u will be sine u. Since this does not involve limits, I'll bring my constant plus c. So my final answer will be 1 on 3 sine. But do I know u? Yes, I know u to be 3x plus 7 plus this constant c. So this is the final answer by substitution. You can do it straightforward and use the shortcut approach to integrate if it is an objective question, because we know that functions like this, you have to differentiate this, which is 3, then divide it by that and change the differentiate the cos too. When I integrate cos, I'm going to get sine, and here I got 3, so I have to divide by the 3, then bring the same thing, which is 3x plus 7. And now it is an integration, so plus my c. Are we okay? All right, so that's that example. Example 2. Let's see the integral of 2x minus 5 all raised to the power 7 dx. We are to integrate this. If you are to expand this raised to the power 7, you are going to get many terms before you do them integration individually. But with the idea of substitution, we can just integrate this and move away. So now I can let the u be equal to the whole of that, which is 2x minus 5. After letting your u be equal to that, because I want to get rid of the dx, I have to find a way, which is du dx, and I'm going to get 2, meaning my dx is now equal to du on 2. Are we okay? So this whole function is now going to be equal to integral of this whole thing is now u raised to the power 7 on the x. The x is now du on what? 2. So I can factorize the 1 on 2 out, leaving integral of u 7 by what? Du. So integral of u to the power 7 is going to be u to the power 8 on what? 8, and plus my c, which is equal to 1 on 16 u8 plus c. So I can bring in the value of what? U now. So now the integral is going to be 2x plus 5 all raised to the power 8 plus c. That's the integral for this function. Are we okay? It's very simple. We can also look at this example and see how best we are going to solve it. So the third example, let's find the integral of e function, which is raised to the power 5x plus 2 with respect to x. If you are asked to integrate this, you can use the method of substitution very easily. So I will let this whole 5x plus 2 be a certain variable, say u. Let u be equal to 5x plus 2. To get rid of dx, I will differentiate the u with respect to dx is going to give me what? 5. Meaning my dx is du on 5. Are we okay? So that I can get u in terms of what? U. So this integral is going to be, the e is now raised to the power, this whole thing, u, and my dx is du on what? 5. I can factorize 1 on 5 out, integral of eu du. But we know the integral of what? And on 5, this, if you integrate e to the power what? U, you are going to get back e to the power what? U. So which is the same thing, eu plus the constant c. And finally, I can bring in the value of u to be e 5x plus 2 plus my constant c. And this is the integral of this function by substitution. Let's look at the third or the last example that we will solve. If I'm to find the integral of x ex square, then let's say dx. Are we okay? Here, can I let u become one of the x or this? Yes. So I can say let my u be x square. Then my du dx is going to be what? 2x. Therefore, dx is du on 2x. I'll begin to bring it back. This is going to be integral of, remember you have your x here, this whole thing is u now, the x is now du on what? 2x. Because we are now trying to work in u's, this x can take care of this, giving you integral, and I'll factorize this one on 2 out. Integral of eu du, and you know how to go by this, which is 1/2 eu plus c. Then straightforward, we can get our integral to be 1/2 e s squared plus our c, and this will give us what? The integral of this function. You can use differentiation by parts, but when we get there, we will also try solving that. Thank you for watching this episode. This is just the beginning.